Hi there, in today's video we're going to look at covalent bonding. Covalent bonding is different to ionic bonding because covalent bonding is sharing of electrons. Ionic bonding was when we gave or lost electrons. Covalent is sharing electrons, so we're going to share electrons, not give them away or take. So it's all about sharing. So sharing of electrons. As like all bonding, we want to make sure that we have full, stable outer shells. Now in our case, that's going to be either 2 electrons if it's the first shell, or 8 electrons in any of the other shells. So we're only ever going to look to make a maximum of 2 in the first shell, or 8 electrons in the outer shell. That's what we're going to say is full. So that's what we're going to look for. The other thing about covalent bonding is that it is between non-metals. So it's non-metal to non-metal. How is that different to ionic bonding? Let's do some examples of covalent bonding. We'll start with hydrogen. Hydrogen is a group 1 element, so it has 1 electron in its outer shell. It's got 1 valence electron. So we can draw an atom of hydrogen like this. We'll do a cross diagram. Now when hydrogen bonds, it's going to bond to another hydrogen, it's going to make a hydrogen molecule, because hydrogen likes to go in pairs, because it wants a full shell. And to get a full shell it needs 2 electrons, so it's going to share with another hydrogen atom. So there's another hydrogen atom, there's its electron. So now you can see they are sharing each other's electron, which gives them 2 electrons for this hydrogen, and this one has 2 electrons. So they are sharing. So this is a hydrogen atom, H atom. This is a H atom. And this is a hydrogen, or H2, molecule. Okay? Covalent bonding, sharing of electrons. Let's take another look. Let's have a look at another example where we might involve more than 1 pair of electrons. Let's have a look at oxygen. Oxygen is group 6, so it has 6 valence electrons. So first shell has 2, second shell has 6. I'm going to do 2 there, 2 there, and I'm going to do 2 there, like that. The reason I've done that is because these are the ones that are going to get shared with another molecule. Now to do this, I'll do the outer shell first, then we'll do the inner one, and I'll just write oxygen there. 2 inside 2, and then 6 in its outer shell, but it's going to share 2 pairs. Now they both have 8 in their outer shell. Let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8 in this atom. 1, 2, 3, 4, 5, 6, 7, 8 in this atom. So now we've got 2 oxygen atoms sharing 2 pairs of electrons to make 8, a nice full outer shell. So this is an oxygen molecule, O2. What about when we have elements that are not the same? Let's do that next. Right, let's look at water, H2O. Right, a nice common compound, one that you should be familiar with. We know it's got 2 hydrogens and 1 oxygen. They're both non-metals, so they're going to bond by covalent bonding. So let's draw our oxygen first, because it's the bigger one, and it's just easier to fit it all in. So we know it's group 6, it's got 6 valence electrons, electron configuration of 2, 6, which means it's got 2 on the inner shell, and then 6 on the outer shell. Now this time, I'm going to draw it, let's say, how we can do this? Do 2 there, 2 there, 1 here, see that, and 1 there. Let's draw our hydrogens in, so we know it has 2 hydrogens, and we're going to share this electron here. So there's our hydrogen, it's only got 1 shell, and there's the other one. So now hydrogen, this hydrogen atom has 2 electrons in its first shell, so it's full, it's nice and stable, it's happy. This one here has also got 2, it's sharing these 2, so the hydrogen is sharing this one with the oxygen is sharing this one with the hydrogen, so that's happy. And the oxygen, let's count them, 1, 2, 3, 4, 5, 6, 7, 8. that second shell's got 8 electrons, it's happy. So we've got H2, 2 hydrogen, 1 oxygen. Happy days, we are good. Let's do this molecule here, CH4. This is a common covalent compound, often used in gas in the lab. So we've got propane, but in my lab in England we use methane. So this is called methane. So the name of this molecule here is methane, CH4. Okay, CH4 is methane. We've got carbon. Let's start with carbon. Group 4, 4 valence electrons. Right, it's got an electron configuration of 2, 4, because its atomic number is 6. So carbon, 2, and then outer shell has 4 electrons. It wants to have 8 to be nice and stable. Because it's a non-metal, hydrogen's a non-metal, we're going to have covalent bonding. So it's going to share these with hydrogen. So now you can see we've got 4 hydrogen, H4, the little subscript means there's 4 hydrogen, and we've got 1 carbon, CH4. 2 electrons in this shell of hydrogen, happy. 2 here, happy. 2 here, happy. 2 here, happy. How many in the carbon now? 1, 2, 3, 4, 5, 6, 7, 8. 8 is happy. We're going to do one more example quickly. This one we're going to do NH3. This is called ammonia. Another common compound that you should be familiar with and you need to learn. Ammonia. Let's do nitrogen first. Group 5, atomic number 7, electron configuration of 2, 5. So first shell has 2 electrons, second shell has 5. Alright? 1, 2, 3, 4, 5. We want these to pair up. Because we know there's 3 hydrogens, we know we need to have 1 hydrogen on each electron, so I'll spread it out like that. Then we'll draw our hydrogens in. H, H, H. Again, 2 electrons in this shell, happy. 2 electrons here, happy. 2 here, happy. And how many in this last shell? 1, 2, 3, 4, 5, 6, 7, 8. Happy. I think you get it. I've repeated it enough. So 3 good common examples of covalent compounds. Learn them, learn this process. Covalent bonding is the sharing of electrons between non-metals. That's it. See you soon. Bye.